Jai Hind everyone, myself Dr. Ganika, Assistant Professor in Department of Applied Sciences and Humanities, Ajay Kumar Garg, Engineering College, Ghaziabad. Today I am discussing the topic of engineering mathematics first. The code of the subject is BAS 103 and the topic is gamma function and beta function and the properties of gamma and beta function. Firstly, the gamma function is used to find the definite integral of this type, integration 0 to infinite e power minus x, x power n minus 1 dx. So gamma function is denoted by gamma n, and gamma function or Eulerian integral of second kind is equals to integration 0 to infinite e power minus x, x power n minus 1 dx. So to find the value of gamma 1, we will put here n is equals to 1. So gamma 1 is equals to integration 0 to infinite e power minus x dx. Now integration of e power minus x is equals to minus e power minus x and the limit 0 to infinite. Now we will put the limits, the upper limit and minus sign the lower limit. So here we will put x is equals to infinite, so e power minus infinite is equals to 0, and now minus sign we will put here x is equals to 0 and e power 0 is equals to 1. So value of gamma 1 is equals to 1. Now some basic formulas of gamma function. First formula is gamma n plus 1 is equals to n gamma n, where n is positive. So to prove this formula, we already know that by the definition of gamma function, gamma n is equals to integration 0 to infinite x power n minus 1 e power minus x dx. Now we will integrate this integration by parts rule. We assume this is first function and e power minus x, this is second function. So first function as it is, and integration of e power minus x. Integration of e power minus x is equals to e power minus x upon minus 1, and minus sign. Now integration differentiation of first function, differentiation of x power n minus 1 is equals to n minus 1 into x power n minus 2, and integration of second function, integration of e power minus x is equals to e power minus x upon minus 1. Now we will simplify this. Now we will expand e power minus x, and we know that expansion of e power minus x is equals to 1 minus x upon factorial 1 plus x square upon factorial 2 plus up to minus 1 power n x power n upon factorial n plus up to infinite, and into x power n minus 1 as it is, and plus n minus 1. Now we will integrate x power n minus 2 into e power minus x with the limit 0 to infinite. So now if we put x is a limit x tends to 0, if we put here x is equals to 0, then there it will be equals to 0. Now and plus n minus 1 integration 0 to infinite x power n minus 2 into e power minus x, and this is by the definition of gamma function, it will be equals to gamma of n minus 1, because of gamma n is equals to integration 0 to infinite e power minus x, x power n minus 1 dx. Now we will replace n by n minus 1, n by n minus 1. So gamma n minus 1 is equals to integration 0 to infinite e power minus x and x power n minus 2 dx. So this integration is equals to gamma of n minus 1. So gamma n plus 1 is equals to n gamma n by replacing n by n plus 1. Now second formula is gamma n plus 1 is equals to factorial n, where n is a positive integer. Now to prove this formula, we will replace n by n minus 1 in equation 2. In equation 2. So gamma n minus 1 is equals to n minus 2 gamma of n minus 2. Now putting the value of gamma n minus 1 in equation 2. So gamma n is equals to n minus 1 into n minus 2 gamma of n minus 2. Now again gamma of n is equals to, similarly gamma of n is equals to n minus 1 into n minus 2 up to 3 into 2 into 1 gamma of 1, and we know that gamma of 1 is equals to 1. So gamma n is equals to n minus 1 n minus 2 up to 3 into 2 into 1, and this is equals to factorial of n minus 1. So now replacing n by n plus 1, we get gamma of n plus 1 is equals to factorial n. Now if n is a positive fraction, then by repeated application of above formula, we get gamma of n is equals to n minus 1, n minus 2, and go on decreasing by 1. Now to find the value of gamma of 11 by 4, we can write gamma of 11 by 4 as 1 plus 7 by 4, and now we will use this formula, gamma of n plus 1 is equals to n gamma n. Now put here n is equals to, here n is equals to 7 by 4. So this is equals to 7 by 4, gamma of 7 by 4. Now again we can write gamma of 7 by 4 is equals to 1 plus 3 by 4. Here n is equals to 3 by 4. So this is equals to 3 by 4 and gamma of 3 by 4. So this is the value of gamma of 11 by 4. Now to find the value of gamma of 1 by 2, so gamma of 1 by 2, we know that gamma of n is equals to integration 0 to infinite e power minus x, x power n minus 1 dx. Now we will put here n is equals to 1 by 2. So gamma of 1 by 2 is equals to 0 to infinite e power, here we can take here t. So e power minus t and t power 1 by 2 minus 1 by 2 minus 1 dt is equals to integration 0 to infinite. So t power minus 1 by 2 and e power minus t dt. Now let y is equals to under root t. So dy is equals to dt upon 2 under root t. Then gamma of 1 by 2 is equals to 2 integration limit of t will replace by limit of y. So y is equals to 0 to infinite, and e power value of t is equals to y square. So e power minus y square and dy. Now we can integrate this by using y square and this is equals to under root pi. Now to evaluate the negative sign of 1 by 2, gamma of negative sign of 1 by 2. So to find the negative gamma of negative values, we will use this property, gamma of n plus 1 is equals to n gamma n. Now we will put here n is equals to minus 1 by 2. So this will be equals to minus 1 by 2 plus 1 and is equals to minus 1 by 2 gamma of minus 1 by 2. Now we will simplify this, then this will be equals to gamma of 1 by 2 is equals to minus 1 by 2 gamma of minus 1 by 2 is equals to gamma of 1 by 2 is equals to under root pi is equals to minus 1 by 2 gamma of minus 1 by 2. So is equals so this imply we know that gamma of 1 by 2 is equals to under root pi. So this imply that gamma of minus 1 by 2 is equals to minus 2 under root pi. Now beta function. So beta function is denoted by beta mn or bmn. Beta mn or bmn, where m and r positive values, and beta function is a definite integral, integration 0 to 1 x power m minus 1 1 minus x power n minus 1 dx. Now beta function is a symmetric function, that is beta mn is equals to beta of nm, where m and n are positive values. Now some properties of gamma function and beta functions are: first property is beta mn is equals to integration 0 to infinite x power m minus 1 upon 1 plus x power m plus n dx. Now Second property is integration 0 to pi by 2 sine power p theta cos power q theta d theta is equals to gamma of p plus 1 by 2 gamma of q plus 1 by 2 upon 2 into gamma of p plus q plus 2 upon 2. Now to prove this property, we already know that by the definition of beta function, beta mn is equals to integration 0 to 1 x power m minus 1 1 minus x power n minus 1 dx. Now we will put x is equals to sine square theta. We will convert this integration in the polar form. Now put x is equals to sine square theta, then differentiate this, dx is equals to 2 sine theta cos theta into d theta. Now so 1 minus x is equals to 1 minus sine square theta. So 1 minus sine square theta is equals to cos square theta. Now we will put all these values here. We will replace the limits also. If value of x is equals to 0, then theta will be equals to 0, and if value of x is equals to 1, so 1 is equals to sine square theta. So theta is equals to pi by 2. So limit 0 to pi by 2, value of x is equals to sine square theta, so sine power 2m minus 2 theta, and value of 1 minus x is equals to cos square theta, so cos power 2n minus 2 theta, and into value of dx is equals to 2 sine theta cos theta d theta. Now we know that beta mn is equals to, this is the property of beta function and gamma function. Beta mn is equals to gamma m gamma n upon gamma of m plus n. So is equals to, we will put here the value of beta mn gamma m gamma n upon gamma m plus n is equals to 2 integration 0 to pi by 2 sine power 2m minus 1 theta. We simplified this. So integration, so this is equals to sine power 2m minus 1 theta cos power 2n minus 1 theta and d theta. Now we will assume 2m minus 1 is equals to p, so m is equals to p plus 1 by 2, and assume 2n minus 1 is equals to q, so n is equals to q plus 1 by 2. Now put these value of m and n in this equation. So gamma of p plus 1 by 2 gamma of q plus 1 by 2 upon gamma of p plus q plus 2 upon 2 is equals to, and 2 integration 0 to pi by 2, value of 2m minus 1 is equals to p, so sine power p theta, value of 2n minus 1 is equals to q, so cos power q theta d theta. So now integration of sine power p theta cos power q theta over the limit 0 to pi by 2 is equals to gamma of p plus 1 by 2 gamma of q plus 1 by 2 upon 2 into gamma of p plus q plus 2 upon 2. Now the property of beta and gamma function, and we can say the relation between beta and gamma function. So beta mn is equals to gamma n upon gamma m plus 1. Now we will prove this. We already know that by the definition of gamma function, gamma m is equals to integration 0 to infinite e power minus t power m minus 1 dt. Now we will put t is equals to x square. Now integrate this, so dt is equals to 2x dx. So gamma m is equals to 2 integration 0 to infinite e power minus x square. Put here the t is equals to x square, and here t is equals to x square, so x power 2m minus 1, and value of dt is equals to 2x dx. Now similarly we can say that gamma n is equals to 2 integration 0 to infinite e power minus y square y power 2n minus 1 dy. Now we will multiply these equations. Gamma n is equals to 4 integration 0 to infinite this integration e power minus x square x power 2m minus 1 dx into this integration 0 to infinite e power minus y square y power 2n minus 1 dy. Now we will simplify this. So for double integration with the limits, both the integrations have limits 0 to infinite e power minus x square plus y square into x power 2m minus 1 into y power 2n minus 1 dx dy. Now now we will convert this integration in polar form, and to convert in polar form, x is equals to r cos theta, y is equals to r sin theta, and x square plus y square is equals to r square cos square theta plus r square sin theta square theta. Here r square is common, so r square into cos square theta plus sin square theta, and value of cos square theta plus sin square theta is equals to 1. So x square plus y square is equals to r square, and theta is equals to tan inverse y upon x. Now gamma n is equals to, now we will put all these values in this integration. So value of x square plus y square is equals to r square, value of x is equals to r cos theta, value of y is equals to r sin theta, value of dx dy is equals to r dr d theta. So put all these values in the previous integration. Now we will separate the integration with respect to r and the integration with respect to theta. So here we take the terms of r, and here the terms of theta. So e power minus r square r power 2m plus n minus 1 dr, and integration 0 to pi by 2 cos 2m minus 1 theta sin power 2n minus 1 theta and d theta. Now we take 2 with this integration and 2 with this integration. So this is equals to beta mn. This integration is equals to beta mn, and now to integrate this integration we will put r square is equals to t. So by the differentiation 2r dr is equals to dt. Now we will put these all these values in the previous integration. So gamma n is equals to integration 0 to infinite e power minus t power m plus n minus 1 dt, and plus this integration is equals to beta mn. And now by the definition of gamma function, gamma n is equals to integration 0 to infinite e power minus t gamma m t power m minus 1 dt. So if we take gamma m as gamma m plus n, so gamma m plus n is equals to integration 0 to infinite e power minus t and t power m plus n minus 1 dt. So this integration is equals to gamma of m plus n. Now we will take this term in left hand side. So beta mn is equals to gamma n upon gamma m plus n. Now next property of beta function is beta mn is equals to 2 integration 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. We already used this property in this proof of beta relation between beta function and gamma function. Now now next property is integration 0 to infinite x power n minus 1 upon 1 plus x dx is equals to pi upon sin n pi, where n is the range between 0 to 1. So gamma n into gamma 1 minus n is equals to pi upon sin n pi. So this integration is equals to gamma n and gamma 1 minus n, and value of this gamma n gamma 1 minus n is equals to pi upon sin n pi, where n is from 0 to 1. Now duplication formula. So duplication formula is important, and gamma m into gamma m plus 1 by 2 is equals to under root pi upon 2 power 2m minus 1 into gamma 2m, where m is positive. Now to prove this duplication formula, gamma, we already know that integration 0 to pi by 2 sin power 2m minus 1 theta cos power 2n minus 1 theta d theta. We are using this property is equals to gamma n upon gamma m plus 1, because gamma beta mn is equals to gamma n upon gamma m plus n. So we are using this property here. Now we will put 2n minus 1 is equals to 0. So this implied that n is equals to 1 by 2 in this equation. So integration 0 to pi by 2 sine power 2m minus 1 theta d theta is equals to gamma m under root pi upon 2 into gamma of m plus 1 by 2. Now again putting n is equals to m in first equation. So integration 0 to pi by 2 sine power 2m minus 1 theta cos power 2m minus 1 theta d theta is equals to, so here put m is equals to n, so gamma m whole square upon 2 into gamma of 2m. Now we will multiply and divide this integration by 2 power 2m minus 1. 2 power 2m minus 1. So this term is equals to sine 2 theta, and now we will assume 2 theta is equals to phi. So by the differentiation 2 d theta is equals to d phi. So this integration is reduced to 1 upon 2 power 2m integration 0 to pi by 2. If limit of theta is 0, then limit of phi will be is equals to 0, and if value of theta is equals to pi by 2, then is equals to phi by 2, then phi is equals to pi. So 1 upon 2 power 2m integration 0 to pi sine 2m minus 1 phi d phi is equals to gamma of m square upon 2 gamma of 2m. Now we will multiply by 2. So then limit will be changed 0 to pi by 2. So 2 upon 2 power 2m integration 0 to pi by 2 sine power 2m minus 1 phi d phi is equals to gamma of m square upon 2 gamma of 2m. Now replacing phi as theta. So integration 0 to pi by 2 sine power 2m minus 1 theta d theta is equals to 2 power 2m minus 1 gamma of m whole square upon 2 into gamma of 2m. And now by equation third and by equation second, integration 0 to pi by 2 sine power 2m minus 1 theta d theta is equals to this by equation second, and by equation third gamma integration 0 to pi by 2 sine power 2m minus 1 theta d theta is equals to this. So now we will simplify this and get the duplication formula gamma of m plus 1 by 2 is equals to under root pi upon 2 power 2m minus 1 into gamma of 2m. Now here are some examples by using the properties of beta function and gamma function. First example is integration 0 to infinite x power 1 by 4 e power minus under root x dx. So now we will evaluate this integration by putting under root x is equals to y. So x is equals to y square, by the differentiation dx is equals to 2y dy. Now now we will put the value of x, value of under root x, value of dx in equation 1. Then integration is equals to integration 0 to infinite y power 1 by 2 e power minus y into 2y dy. Now simplify the value the powers of y, then this is equals to 2 integration 0 to infinite e power minus y and y power 3 by 2. We can write 3 by 2 as 5 by 2 minus 1. So by the definition of gamma function, gamma n is equals to integration 0 to infinite e power minus x power n minus 1 dx. So here the value of n is equals to 5 by 2. So this is equals to 2 gamma of 5 by 2. So now to find the value of gamma of 5 by 2, we can write gamma of 5 by 2 as 1 plus 3 by 2. Now by using this property gamma of n plus 1 is equals to n gamma n, here value of n is equals to 3 by 2. So this is equals to 3 by 2 gamma of 3 by 2. Now to find the value of gamma of 3 by 2, we can write gamma of 3 by 2 as gamma of 1 plus 1 by 2. So this is equals to 3 by 2 into 1 by 2 and gamma of 1 by 2, and we already know that gamma of 1 by 2 is equals to under root pi. So this is equals to 3 by 2 into 3 by 2 into 1 by 2 under root pi. Now by the simplification, this is equals to 3 by 2 under root pi. Now The second integration is integration 0 to 1 x power 3 by 2 1 minus x cube and whole power minus 1 by 2 dx. Now we will put x is cube is equals to y, then this imply that x is equals to y power 1 by 3. So by the differentiation dx is equals to 1 by 3 y power minus 2 by 3 dy. Now put all these values in this integration, then integration is equals to integration 0 to 1 y power 1 by 2 1 minus y power minus 1 by 2 into value of dx is equals to 1 by 3 y power minus 2 by 3 and dy is equals to, by simplify the value of the powers of y, then y power minus 1 by 6 1 minus y power minus 1 by 2 and dy. Now we can write minus 1 upon 6 as 5 by 6 minus 1 and minus 1 by 2 as 1 by 2 minus 1. Now by the definition of beta function, we know that beta mn is equals to integration 0 to 1 x power m minus 1 minus x power n minus 1 dx. So here value of m is equals to 5 by 6 and value of n is equals to 1 by 2. So this integration is equals to beta 5 by 6 comma 1 by 2. Now by using this property of beta function and gamma function, beta mn is equals to gamma n upon gamma m plus n. So value of m is equals to 5 by 6, value of n is equals to 1 by 2. So this is equals to 1 by 3 gamma of 5 by 6 into gamma of 1 by 2 upon gamma of 4 by 3. Now we know that gamma of 1 by 2 is equals to under root pi. So we put the value of gamma of under root pi. Now we can write gamma 4 by 3 as gamma of 1 plus 1 by 3. Now by using this property, gamma of n plus 1 is equals to n gamma n. So this will be equals to 1 by 3 and gamma of 1 by 3. So 1 by 3 gamma of 1 by 3. Now we will multiply and divide by gamma of 1 by 6 into gamma of 2 by 3 in numerator and denominator. Now value of we will use the property of gamma n, gamma of 1 minus n is equals to pi upon sine n pi, because gamma of 1 by 6 and we can write gamma of 5 by 6 as 1 minus 1 upon 6. So this is equals to pi upon sine, value of n is equals to 1 upon 6. So pi upon 6. And now the value of gamma of 1 by 3 and gamma of 2 by 3, we can write gamma of 2 by 3 as gamma of 1 minus 1 by 3. So and here gamma of 1 by 3. So this is equals to pi upon sine pi by 3. So now put all these values here and simplify. Root pi cancel, and now under root of 3 pi gamma of 2 by 3 upon gamma of 1 by 6. Now to prove this property, we will take left hand side and then prove right hand side. We take left hand side beta lm dot beta l plus m n dot beta l plus m plus n comma p. Now we will use the property of beta function and gamma function. Beta m n is equals to gamma m gamma n upon gamma m plus n. So here m is equals to l and n is equals to m. So gamma l gamma m upon gamma l plus m. Now the second term beta l plus m comma n, the value of m is equals to gamma l plus m and the value of n is equals to n. So this is equals to gamma l plus m dot gamma n upon gamma l plus m plus n. Now this term beta l plus m plus n comma p, now here m is equals to l plus m plus n and n is equals to p. So this is equals to gamma l gamma m plus gamma l plus m plus n and dot gamma p upon gamma of l plus m plus n plus p. Now we will use this property. this now we will simplify this term is cancelled and this term is also cancelled. So we will find gamma L, gamma M, gamma N, gamma P upon gamma L plus M plus N plus P. So we will prove the right hand side. Now these are the references books. Thank you.